visual simulation.
Thank you, Kevin. Good afternoon, everyone. By the way, there is a secret competition in this conference. Where is the longest presentation title? I think I'm going to be at the top of that one. I want to acknowledge some other participants in this study, my students, and David Wasserman, who was one of the authors of some of the work that we're going to present here. Pick the wrong pointer. Green button, the big green button. So the problem that we're looked at, traditionally, if you have in traditional modeling, you build an existing model, and then you try to create variation of the proposal, right? And if your scenarios are complex, basically you have to spend a lot of time by manually building them. Essentially for high load repetitive work, that at some point gets unproductive. Take, for example, complete streets. Complete streets require more complex street configuration because they consider not only the road component, but also the public realm, the sidewalk, the median, and all of the components that in order to accommodate multiple modes, and all users. So in this case, if you look at complete streets, we've identified about 170 different variables that you can manipulate to be able to build all sorts of configurations. And that could be very time-consuming if you're trying to do it manually. So we're wondering what would be some good ways to try to find alternative on how to create quick design, street design scenarios using rule-based modeling rather than traditional manual modeling. So our research objective is to investigate essentially the rule-based modeling as a scenario-oriented design tool. For this work, we use City Engine. How many people are familiar with City Engine? Okay, it's ESRI, who's create ArcGIS software, and they basically purchased this company, and it's getting more integrated with the GIS software. So what is rule-based modeling, or also known as procedural modeling? This is where you write code. You develop the model, the geometry, the textures, by writing code, not picking tools and manually building. So you would start with a GIS foundation. You have the building footprints, the street center lines, and so on. You would import them into a rule-based software. As I said, this case we're using City Engine, and so I'm going to make some references to it, but conceptually would work similar in other software. The rule-based modeling, this particular one is called, the programming language called CGA, computer-generated architecture. In fact, in the architectural world, there's been efforts done for many years to try to automate shapes and so on by this concept of computer-generated architecture. And then, voila, you have the 3D model. For example, in this case, on the picture on the left, we have a roadway with multiple lanes. Let's say that we want to put a median in the center section. In rule-based modeling, you would apply some of the parameters that's showing below the images, like the type of the median, in this case it's a median, or the type of the center section, in this case is a median, the ground cover, the spread of the trees or other objects that you want there, and then once you choose the parameters, then you have that median shown on the right. So the code to generate that, it's more than just those 4 lines of codes that I showed you, but the essence is that there is a user interface that is familiar with the way that we work with pick lists and so on, with parameters, that all these variables are exposed, and you can then manipulate, change interactively, and get productive with this tool generation. In this case, to achieve what we see on the right, you essentially will be picking the variables that are highlighted in the red boxes, such as the median type, the width of the center. How do you want the trees distributed? Are we on trees or other objects there? And you very rapidly would have a scenario with a median. So the the ESRI developed this rule-based complete street rules that are included in the city engine. For us to have a sense of how to organize it, you can look at it in three categories. The objects or variables associated with the sidewalk, things like you have several zones there, like the furniture zone, the pedestrian zone, and the frontage zone, plus variables like sidewalk width, sidewalk texture, bus stop location, and so on. Likewise, for intersections is the second category. You have multiple kinds of objects you can manipulate, as well as for the segment or the traveled way. That's where you could choose all sorts of configurations. So how does this work? I have a little video that shows real-time how this is done in City Engine. So essentially, you would go to the area you want. For now, we're going to just draw the center line that connects those segments, and you've got the street pretty much with default values. Then we can go in the panel that manipulates those variables to start making changes. For example, we change the width of the sidewalk. This is recording of a real-time operation, so you can see essentially how long it takes. And then we can start to change, say in this case we put a median, right? And then we can look at other component of this configuration. Say if we wanted to, see, I need to put some street lamps, right? We'll put the street lamps on both sides. You could choose to put them in one side. Then we can include some bike lanes. For example, one scenario, like the one, a bike lane with two directions. And then we can put a divider, a buffer from the traffic if we wanted to, and then we can configure the buffer with dividers like that, spread them around the amount of the distance you want. Plus, you can plug in automobiles, objects, automobiles, pedestrians, bicyclists, by specifying percentage you want to show in there. Then also context is important, right? And I think DOT is now starting to relate to that. I teach urban design, so I can, the moment I get to talk about context, I can keep going and going. But those buildings that you see there are also built with rules. For this, we loaded a different set of rules. They are building that allow you to essentially apply rules to different property parcels to control the setback, the height of the building, the architecture. This is rule generated, even the texture on the building, and then roofs and so on. It goes on and on and on. So there you have it. By the time that I talked, we really built that scene there. So we wanted to play more around with this to explore, to see what we could learn from it. So we picked a case study, a segment of a road in Gainesville, near Gainesville, it's where the University of Florida is, near a mall, and it's an area where the city is planning to make some changes. Also is easy accessible for us as a research team to visit there. So we looked at developing three scenarios. The city has only proposed to basically pave, do some pavement, shoulder pavement, to improve safety perhaps. So we looked at three scenarios. We generated more, but we picked three for this presentation. So one is to increase transit ridership, and the solution for that was to add bus lanes. Then you can see for each of the components, intersection, traveled way, and sidewalk, the variables in red show the changes that we had to make by the default rules. And by making those changes, then you would get a different scenario. So we added a scenario to increase to bike traffic on that segment, and then we had two scenarios for bike. One where bikes are separated on each side of the road, and one where they are on one side of the road. That just for essentially a way to explore options. So as a result, we created these various scenarios that compare the current condition with street design scenarios in the current context and street design plus changes of the context. So that's scenario number 1, current condition. You can see the line widths, and this is what it is there now. And I have to tell you, look prettier than it is in reality. The model makes it look really good, even if it's... so then we started to look at the first scenario is to add a bus lane, and you saw how that, you can imagine how that can be done through that interface. On both sides, we added median. This has a larger median, has bike lanes with dividers, narrow automobile lanes. And then this is the scenario that has both bike lanes on one side. Then let's see how these would change with the context. So this is the bus route now with a new context, right? This is a typical suburban area, but the city has mixed use, mixed development planning here based on their land use and zoning code. So this is how this could look, and we could generate this with those parameters. Next is the bike path on both sides with the context, and then bike lanes on one side with the new context. So we built, the software has an opportunity, once you build this, you can do interactive visualization using 2 methods. One, building a what's called a web scene, which is basically a web-based 3D viewer that could be exported. I have the links in there, so when you get access to this presentation, those are posted. You can basically explore those interactively. And the other one is VR. Essentially, exports into a VR scene, and I think it uses the Unity engine to do it. So here's a video of how the interactive 3D website works, right? So on the right there is a table of contents where there's various layers that has all the different components that it put this together. So we exposed all of them to allow maximum flexibility for combination. So you can see it's just like a typical GIS software. You turn layers on and on, more or less, but you can combine them to see these various scenarios. In case I forget to mention, this tend to work better in Google Chrome. The other browsers don't seem to handle it as well. What this does that we like, you could have these bookmarks, spatial bookmarks of the views at the bottom. You can set a few of those. You can press play button and it flies through making those bookmarks. So in a sense, it creates some crude animation if you want to explore the space that way, but it's pretty effective, very low cost. So you can see, for example, you could create movement by just inserting more bookmark, and for you that are familiar with animation, these are like keyframes that you can just set them up when you post the web scene. So I invite you to really check these out and then just explore them interactively. Now, this also have this comparison tool. Like a previous presenter, you see the slider, the comparison where it's, for example, the same scenario without context and then with context. It also has a side-by-side comparison, which my student left it out, which it can be static. It split the screen, it shows them side by side or on top of each other if you wanted to see it in that direction. Now, this is also an effective tool for public participation. You can go in there, click somewhere on the scene where you want to make a comment, type the comment, and the comment becomes part of the scene, and then one can go in and then look at the comment. So if you put this out for broad public input, you could go in there, pull up all those comments, and read the comments right there in the interactive scene. This one is the second method, which is the VR, and I have to say that this video does not do it justice. You really have to watch in the goggles. So we put this the method was relatively straightforward. You export it from the software into a VR scene, which we loaded in an Oculus Go, which doesn't need an iPhone or anything. It just loads the actual video on the scene, the VR scene, on the device itself, and then you could just watch it. It looks a lot better when you do it that way. What this has is an opportunity to create this menu where you can place your point of view anywhere you want, obviously, and then interactively switch the scenario. So you can choose now we're looking at various scenarios from that point of view. Right? You can see, for example, the bike lanes on both sides. And we're changing now to, this is a bus route scenario with context and so on. And then obviously textures and all those other elements there are parametric, right? You could change them interactively, not in the VR scene, but in the software itself. So if you want to create more variations to say, just ask people which texture they like, then that's pretty straightforward. And this works, I guess, like most VR. You point your handheld controller to one of these bullets on the scene, and it jumps to that particular scene. So to wrap up here, we confirm that, once these rules are built, then the effort to really create these scenarios, it's minimal. So this chart comes from City Engine, where they've done an analysis where basically they claim the procedural modeling, take that curve, flattened curve, regardless of the amount of work that you put in there, and we're able to confirm that. Now, the basic rules that come with City Engine for streets are about 300 lines of code somebody from the company wrote. So then, our students, which worked for ESRI, developed the rest of the complete street rules. He had to build about 3,000 lines of codes to be able to manipulate about 120 data elements to create all those variations. But now that they're there, the rest of us can enjoy them and be very productive to generate these scenarios. Another thing that we found useful is that this georeference, the ability to work on in a georeference framework, a geospatial framework, is critical. This particular one, and I think any software that is a capability that can handle this would make the work of creating design scenarios very efficient. In this case, we just use one software. So we imported the footprint and the basic GIS data from a GIS layer, but then pretty much we worked on this software and then exported the results. We found that it's effective for visual comparison. Say, in this case, we have just a street design, and on the left there's the existing, on the right are all the three scenarios. And we thought it was very effective in communicating the multimodal approach of the street. Anybody really can understand that. We didn't conduct a formal assessment with people and getting opinion and all that. Perhaps that's something we'll do in the future, but it is self-explanatory. And then this is the street plus context changes, and you can see the comparison side by side. Another thing that this work emphasized to us is the importance of the context. Traditionally, DOT and transportation engineers, no offense to anyone, are mostly concerned about level of service, right? But in the recent years, it's become more and more clear that we need to consider not the road, but the street. And I try to point that out to my students, that they're two different things. And so we found that context doesn't make a big difference when you consider street design. And the rule-based modeling, because it's able to handle not only the street configuration, but also the context, can help emphasize the importance of this topic. This also creates opportunities for, as an effective platform to support collaboration. In this conference and others, people talk a lot about public participation and using visualization as a tool for that, which it's undoubtedly powerful. But let's not forget that building streets and highways and so on. It's a complex operation that have all these people that sometimes work on their silos, right? And we know that if you put visualization in front of people, they can start talking because, you know, it's the same language. What I want to point out about the specialty of a parametric modeling or rule-based is that this has an opportunity for rapid change and rapid feedback. So if you think about with the way that our systems are merging between CAD, GIS, and BIM, having a system like this that includes all the components of all the stakeholders, you can have an opportunity to create more efficient collaborations at the professional level. And obviously it goes without saying that public engagement, this could be also a powerful tool for public engagement. Either it's the web-based interactive model that I showed, or a VR, which obviously the public's got to have some. And last, for future, these rules can be expanded. There are only 120 elements that are available. There are another 50 variations on complete street rules that can be added. So here are some examples. For example, you can have the curb extensions model to reduce crosswalk distances or raised intersections with raised crosswalks, mid-block, neck down, or raised bike lane. So these are real-world examples of complete streets that could be modeled. Also, as we're moving toward autonomous vehicles, you can see where you can start considering other scenarios that will, our infrastructure may change. For example, you've got an urban arterial there that looks like that today, but with autonomous vehicles could change, right? We're talking about narrower lanes or dedicated lanes or drop-off and pick-up zones, for example. And you can see how with the complete street rules, that could be easily accommodated. We found that obviously everything is not all rosy. There are some technical challenges. No database is perfect. So when we started the project, our GIS database didn't have all the existing buildings, plus didn't have any trees. So we have to model all the existing trees where they were. The web-based interactive visualization, when you load the scenes on the web, we found this limit between 60 megabyte to 70 megabyte. I think we found the maximum threshold. There are glitches with VR rendering. That was our first cut at VR. I think we need to look at more closely and try to include movement and other things. And then the scope of the CGA current rules is still limited because it doesn't include all the elements that I mentioned, but they could be added in the future. Thank you.
I think we could probably do one question if there's a question.
So did y'all write the code for the rules, or is that included in City Engine?
All right, very good question. So the out-of-box City Engine contains some traditional street rules, as I said. Then one of our co-authors that worked for ESRI as an intern after graduating from the program, he sat there and he wrote the rules. So it's 3,000 lines of code. But those are available. They are actually on the GitHub. They could be included. If you have City Engine, you can just load them up and then start using them.
Cool. Thanks again.
Okay.
All right.